Thank you, Chad. Our next speaker is Erik Franco. Erik is a senior data engineer here at Ibotta. He's been building an event-driven microservice that he's going to talk about and talk about the concept in general. We're going to give him a few minutes to set up, and we're going to try, sorry, Chad, but we're going to try with the a clippy microphone to his lapel so it's a little bit of a better user experience. Erik left it there. Oh, thank you, Heather.
Hello? Okay. Yeah, so my name's Erik. I'm a senior data engineer here at Ibotta, and started Ibotta about 8 months ago and have been really focused on implementing this event-driven architecture uh, with a strong emphasis on the data portion of it. So that's kind of what we're going to be talking about here today. Uh, to start off with, for anybody who's not familiar with event-driven architecture, just kind of go to a like 10,000 feet up view of what it is. It's not supposed to be in depth by any means, but hopefully it gives you enough information to follow along with the rest of the presentation. And then talk about event-centric thinking and what it is, and why should engineers and business leaders care. And then lastly, give you like some insights into a service that we're creating that's specifically event-driven and some of the tools that we use to develop it. So what is event-driven architecture? This is directly from Wikipedia. I did not come up with this, but it really emphasizes exactly what it is, right? It's an architecture pattern promoting the production, consumption, detection, and reaction to events. So let's take an example. So in this example, this is like a mobile banking example, right? And this is a user that has just created a new account and maybe just created a new checking account as well. An event-driven system might look something like this, right? Where a new account request event gets emitted from the mobile phone itself. It goes to the account service, and the account service might create 2 events based on that as well. So it might create a new account event that goes to another service called an identity service that might have some credentials or anything like that. Or it might go to a checking account service that has a I'm sorry, and then a new checking account event goes to the checking account service, which might provision the checking account on behalf of the users, right? This is just a simple example just to get you up to speed. So what is an event, right? An event is a change in state. And to the left is just an example, right? This is a JSON event, but it doesn't even have to be text. It could be binary, it could be some type of messaging format, right? Very important to event-driven architecture is the concept of producers. And producers all they do is really produce events. One of the things they're going to see here a lot is the word decoupled, right? Producers have no idea about other producers in the system or no idea about other consumers in the system. And that brings us to consumers. Consumers consume events, and same logic applies here, right? They're decoupled from the systems, decoupled from other producers, and decoupled from other consumers as well. They have no idea that these exist in the system. There's other things like messaging brokers and things like that, but just high level, this is it. So what is event-centric thinking, and why should engineers or business leaders care? So event-driven architecture isn't actually something new. It's been around for a while, specifically systems communicating between each other using events. What really has changed is the way that people start thinking about events. So on the left-hand side, we have kind of the old traditional way of thinking that's very database-centric, but more specifically, it's very state-centric, keeping the state of the system. So events might might circulate around this, applications and services circulate around this, and analytics as well, whether they do it transitively or not, they're actually going to the database for this type of information. This way of thinking is a little bit more rigid, a little bit more structured, and has some scalability problems as you start to grow. And then the model to the left there is the more event-centric approach where events really become your source of truth. This is an eventually consistent model, but everything revolves around the event itself. So the database, the applications, and the analytics themselves. And it turns out that when you start thinking about events in this way, you start to see some massive benefits. So one of those is respond to changing business requirements, right? So let's use the first example, right? The mobile banking example. And let's say tomorrow our analytics team discovered that you had a 90% chance of having a user opening a savings account if they just opened a checking account, right? Within a 1 week window or something along those lines. That's something that a business would want to capitalize on. And that's something that really drives at the heart as to what event-driven architecture is being able to respond to this type of change. So we might engineer something like this, right? Create a promotional service that becomes a consumer of that new checking account event. That promotional service is in charge of just listening for these events, and it might do something like send a savings account promotional event back to the user. This is like a perfect example of capitalizing on that type of information from a business standpoint, but there's also engineering aspects to it as well. So like, I kept mentioning decoupled systems, and that's really one of the benefits is that we can create this promotional service in tandem with other services as well, right? With an existing service or with multiple services at the same time. But you also get the added benefit of creating services that might use different languages, right? So maybe a service is written in Java, another service is written in Python because there might be some better Python libraries to do that specific function. We can actually keep taking this further by doing event sourcing, and that's really analyzing the event streams or the events in a batch-oriented way. So like earlier in the presentation, I said that an event describes a change in state, but when you really apply that event, it really describes business moments, right? These events start describing business moments, and when you start analyzing these events and putting them all together, you can start getting insights into what's going on in your business. So a good example, just using the banking analogy is real-time fraud detection. That is a good, perfect example for something like this, being able to analyze these events and respond appropriately when something gets detected. One of the things I kind of want to talk about is event streaming versus event batching. There's a lot of miscommunication about this, whether one replaces the other. And it's not really a replacement, they're actually complements of each other. You can do very powerful insights by doing either streaming or batching. And then it drives us back to the original point, right? Why should engineers or business leaders care? And I've been talking about all these like good things that event-driven architecture does from a business perspective and an engineering perspective. The decoupled architecture, the powerful business insights, the fast responsiveness. But what all that really amounts to or equates to is business agility, like increasing a business's agility to make the right decision at the right time. And if there's one thing you get from this presentation, hopefully it's that right there. Just some considerations before adopting EDA. This is coming from us we've been going through it. And I also shamelessly just took this quote from someone online, but legacy systems are only legacy because they've been successful enough to last this long. And that's really a true story. Before you go about implementing EDA, just make sure that you're aware of the full cost that it does cost for a business. For instance, it requires a significant amount of experience. So like when you're implementing these services, you're either implementing with microservices or serverless architecture, and that has its own amount of expertise that you need, but now you're incorporating messaging brokers and things like that. And in a distributed system, you start getting duplicates, messaging orders starts becoming important, things like that. So just be aware that it does require a significant amount of expertise. DevOps mindset goes a long way. So the old way of just kind of chucking it over the fence and letting ops deal with it, you're going to have a really bad time. Just assess whether the long-term business value is worth its short-term difficulties. And then just an example EDA microservice that we're building here. So this is the system event service. It's like a awesome name, right? System event service. But it's primarily responsible for passively listening in on all system events being emitted in the system itself. So it has connectors for things like Kinesis and Kafka, SNS and SQS and things like that. It does some authorization logic there, some validation logic, does some deduplication, streams the events so that our analytics team or any other consumers can start listening in those events as well. And then finally loads it into our data lake. And just some of the tools that we use for that. So AWS, we're a full AWS shop. One of the things that you'll notice about all these tools is that they really allow you to focus on business logic rather than some of that messy logic that you get when trying to deal with infrastructure or event deduplication and things like that. So AWS, managed services, scalability, ease of use. Kubernetes, the big one here is the simple deployment. So you're able to do canary deployments and blue-green deployments pretty easily and deploy things. Very nice Kubernetes. Spring Boot, if you're creating these in Java, for instance, Spring Boot, if anybody's familiar with Spring, you get the dependency injection, the production-ready features like metrics and health checks and things like that. But with Spring Boot specifically, you get the auto configuration and the no XML configuration, which is really nice. Camel, this one's a big one. This is the framework that we use. If anybody's familiar with Camel, it's a Java framework that applies enterprise integration patterns. So this is what really allows you to integrate all these different systems together, especially with the brokers themselves. It also provides really good libraries. So the deduplication was provided by Camel. It was a library that Camel provided in a distributed environment as well. That becomes difficult to do, but Camel had a nice, easy library to use for that. So, and then lastly, protobufs. This is a language agnostic serialization framework developed by Google. And this is what really allows you to use Python, for instance, or Java or Ruby to communicate between all services. It provides schema evolution, which is big for data engineering specifically. When schemas are constantly changing, it can kind of break things downstream. And lastly, we're using it for validation purposes. So just to recap real quick, just EDA requires a different approach to how we think about data, right? It increases business agility, and hopefully that's like what you get out of this presentation, but it's difficult to implement. However, there are tools and techniques available to help you implement it. And that's it. Any questions? No questions?
I was just wondering whether the evolution of this event-driven microservice came about originally, or whether it was the result of maybe difficulties that you encountered with interacting directly with, say, Kafka producers and brokers and like.
Yeah, so we originally came from a monolith system. So we had one giant system that did a lot of different things. And we just started thinking about how we can break these apart and use microservices and use messaging. And then data engineering got involved, and they're like, well, we're going to want to listen to all these streams because we can start getting analytics and insights into that. So that's kind of what started this whole conversation. And that's why a data engineer is here explaining EDA to you guys, and not a platform engineer or anything like that. So right now we're using SNS and SQS to do our messaging brokers. We're using Kinesis streams to do the streaming analytics piece and also a bit of the PubSub model. But we're hoping to move towards ActiveMQ maybe later on, but we really do want to stick in like the AWS ecosystem.
Oh, sorry. I hear SQS is really expensive on high volume. So is that even a concern?
It's always a concern, but it's Ibotta's. That's Scott footing the bill there. No, it's a concern, but I will tell you this. I came from like a Kafka background originally, and that's expensive in terms of manpower just to keep Kafka running, right? You not only have Kafka, but you also have Zookeeper because it needs that coordination piece. And there's a huge problem with Zookeeper and Kafka running in a distributed environment. I won't get into it, but it's nice to have those managed services. It lets you get stuff up and going really quickly. So, any other questions? All right. Thank you.
Thank you, Eric.